So our next target is to talk about propositional equivalences. Okay, so propositional equivalences. So this will talk about equivalences between and among statements. So if we have equivalences in algebra, um, we have also equivalences in math logic, and these are what we call the propositional equivalences. We are trying to check if given sets of propositions are equivalent or not. And there are several ways to check if we to derive equivalences between and among propositional or propositions. Okay, one of the basic propositional equivalences is the commutative property. Okay, commutative property or equivalence property. So when we say commutative property, the truth values of P or Q together with Q or P by constructing a truth table and then compare if they hold to be equal. So in this commutative property, we are referring to P or Q, which is equivalent to Q or P. So this is our first equivalence, propositional equivalence, with regards to statements, propositional logic. Okay, so our target for this topic is to prove, okay, as what I said, I have said a while back, is to prove that this commutative property holds to be true. Okay, is it holds to be true? So ang gagawin natin, we will be proving these propositional equivalences. Okay, so let's say for example, we need to prove that P or Q is equivalent to Q then P. So in this case, we must show their truth values. Okay, we must set the truth table to show the truth values of this. So we'll be having four columns to have or to show the truth table of this equivalence, which is the commutative property. So we will be putting the truth values of your P, we will be putting the truth values of your Q, and we will be putting the truth values of your P or Q and your Q or P. Now take note that our target is to come up equal, okay, yung third and fourth column natin. They should have equal or the same truth values ang ilalabas or mailalabas ng ating dalawang compound statements na yan para ma-prove natin that it is a commutative. It is commute, okay? It has a commutative property itong si disjunction operation, okay? So we are still talking about the disjunction operation with respect to this commutative property. So let's say for example, the truth values of your P are TT, FF, TT, FF. So these are the truth values of your P, and the truth values of your Q will be TF, 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 TF. Okay, so this will be the truth values of your Q. Okay, so that is T. We know, going back to the rule, we know that in the disjunction, we can only say that is a false statement or compound statement if both P and Q are false. Okay? So, dun lang tayo maglalabas ng false statement. So, in this first part or this upper portion of the truth values, we have this to be true, and this will also be true. Since both of these are false, then we can say this is false, this is true, and the last one is false. So, this will be the truth values of your disjunction. Okay? of the compound statement with respect to the disjunction connective. We have T, 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 F, T, 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 F. Okay. Now, our problem is this also be the truth value or truth values of your Q or P? Okay. So we'll also be using the rule, applying the rule for disjunction to be able to come up with the truth values of your fourth column, which is the Q or P. So since we have the same rule, ganun pa rin, if both are true, it is true statement. Okay? It is a true statement. If one is true, then automatically we have a true statement. So true, true pa rin yan. If both are false, still that will be false. So if both are true again, we have true. If one is true, that is true. True. Sorry. We have true. And both are false, we have false. So as you can see, people, itong dalawang ito, we have the same truth values with respect to their arrangement, with respect to their positions. So anong ibig sabihin nito? So ang ibig sabihin nito, that disjunction is has a commutative property or applies a commutative property that represents the disjunction. Okay? So I hope you know now how to prove commutativity with respect to the disjunction connective. Okay? So for our next commutative test, this will refer now to the conjunction. Okay? This will also refer to the conjunction. So when we are proving commutativity property with respect to conjunction, again, we will be utilizing our truth table. Okay? We will be utilizing our truth table. Divide the truth table by four columns. The first column will represent your P. The second will be your Q. Okay? Since we are talking about conjunction, we will deal with P and Q should be equivalent to Q and P. So ito yung ita-target natin ngayon na i-prove. Does it hold? Does it have commutative property? Okay? So we need to show their truth values for you to be able to prove that it applies or it holds commutative property to this given connective. Okay? So the same truth values for your P. We have T, T, F, F, T, T, F, F. Okay? And same truth values for your Q. We have TF, 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 TF. Okay? Then we have P and Q. So when we say P and Q again, we can only have a truth value true in your conjunction if both these statements P and Q are true. Okay? If one is false, automatic, or at least one is false, automatic, the truth value of this compound statement conjunction is false. Okay? So since this P and Q are both true, then automatically we will be having a true truth value. And one is false in the second one, we have automatic to be false. Automatic to be false. And for the third, automatic to be false. Fourth, automatic to be false. And this is again true, false, false, and we have false. So this is the compound statement P and Q, which is located on the left side of the commutative property. Okay, with respect to the connective conjunction. Then for the second one, we have Q and P. So we also need to show the truth values of your Q and P. Okay, Q and P with respect to the truth values of your P statement and your Q statements with the same rule, okay, as what we did in the third column. So since P and Q are both true, or Q and P, sorry, since the left statement is your Q while the right statement is your P, so we start with this going to P. Q from P. Alright? So if Q is T and P is T, then automatic the compound statement P or Q and P will be true. If F or if Q statement is false and your P statement is true, automatic this will be false. If Q is true while P is false, automatic your compound statement with respect to conjunction will also be false. Okay? Then if both are false, automatic your compound statement Q and P will also be false. If both are true, then automatic your Q and P will be true. If your Q statement is F or false, while your P statement is true, then automatic this will also be false. If Q is true and P is false, this is also false based from the rule. And if both are false, automatic that will be false statement. So as you can see from the last two columns in the truth table, we have the same arrangement, we have the same truth value. So what can we conclude? We can say that this P and Q holds or is equal or equivalent to your Q and P. So what can you say then? That conjunction connective is commutative or has a commutative property. Okay, just like with the disjunction. So this is all about the commutative property of propositional equivalences. So thank you again, people. I hope you have learned a lot with my discussion for this video clip presentation. So please monitor. I'll be posting another video clip with or talking about the second property of equivalence, and that is the associative properties. All right. This is also with respect to the operations disjunction and conjunctions. So thank you for watching.